Well, thank you very much for coming to the talk. Yeah, as discussed, it's going to be, this came off the back of Andy's talk a couple of months actually ago. We were having a bit of a chat before the meetup, and I started talking about domain-driven design and CQRS, and I think several people said, "Oh, I've heard about this, but don't really know too much about it." So that's kind of the motivation behind giving a talk on this topic. Let's dive in. A little bit about me first. Yeah, Essex born and bred. Grew up just outside Epping. People know the area. But lived in Chancellor for a couple of years now. And I founded Kiteframe in 2016. We're a consultancy that kind of help organizations, particularly making improvements around like continuous delivery, and helping them increase the rate at which they can like safely and reliably release working and hopefully useful code that provides value to their users into production. And over the last few years in particular, we've had a kind of really strong focus on domain-driven design. It's been really pivotal and influential in how I think about building software, how I build software. We're a current team of 2. I'm currently working with a client in the grocery sector, but I've also got an employee who's engaged with one of our clients in the insurance sector. Yeah, I'm working mainly in Java these days as it turns out, but I've got quite a bit of a history in PHP. So I started off in Java actually. I think Java was probably, yeah, it was the first programming language I ever learned and played around with back in my former days as a mathematician. But yeah, lots of my early client work just happened to be PHP by fate, I suspect. And yeah, I've fitted back into Java. So there will be some Java code later on. I hope that's okay. It's basically PHP, so if you squint really hard, it'll be good. Yeah, no. So without further ado, kind of want to start off with a scenario. I kind of want to imagine you for a second that you've just built a skyscraper, or you're in the process of building it at least, and yeah, you're a little bit worried about it. You've just heard about COP26. You're not completely convinced that the politicians have really got a grasp of this whole climate change thing, and you did learn that London's in a bit of a basin in particular, so you wanted to actually take out insurance for your skyscraper to protect it from flood risk. Really sorry for my lack of artistic talent, but there we go. But the problem with these big kind of scary expensive objects like this is that they're so risky, and they're so expensive to fix that the liability is too big for one insurer to insure. So what happens is a broker, you'll go to a broker. It wouldn't be, you can't just ring up Admiral, they won't help you. You have to go to like a specialty broker. And these specialty brokers will literally take your policy and they'll walk it over to the Lloyd's building. And I literally mean walk it over. In a binder normally, you'll see them walking like down the stairs and across the city and into the Lloyd's building. And they'll go around the various underwriters. Hello, sorry.
Tim, sorry to cut in. We're just still looking at your ID at the moment. Is that expected?
No. That's what's sorry, 2 seconds.
No worries.
I shared the, is it like, if I just stop sharing and share again? Oh, I'll do the entire screen.
It wants a screen, otherwise it won't share other windows. I realised that was what happened when you apologised for artistic ability. I was still looking at code.
Yeah, sorry. Yeah, there we go. Well, okay, so can you, sorry about that. Can you still see the screen now? You can see the whole slide.
Yeah, we're looking at a bit about me.
Yeah,
fantastic, brilliant. Okay, well, the lack of artistic talent was this slide. Which I guess the joke's worn off now, but there we go. Please forgive me. But yes, so if your broker will go down to the Lloyd's building, and you're trying to insure your skyscraper against flooding, let's say. But it's really big and expensive. No one underwriter is going to be willing to take the financial risk of insuring your whole building against even floods. So what they'll do is they'll go and seek out what's called a lead underwriter. They kind of just take the top line of the risk and say, yeah, I'll take 10% of that risk. And then you literally have to go around finding all the other underwriters called followers and they take a little bit more of the risk. I actually had a chance to go around the Lloyd's building once, and I got to see this. Do you know what this? Does anyone know what this is?
Is it some form of ancient ledger?
Is that like some of the oldest debt in the UK?
Not quite. Or you could argue it's potentially debt. It was very quickly debt. This is actually the Titanic's placing slip. So this is what happened when the broker for the Titanic took it to the Lloyd's building, went round the Lloyd's market, and these are all the underwriters that took a little slice, a little split of the share of taking the risk on the Titanic. They're perhaps some of the unluckiest underwriters in history, you could say. But yeah, back some time ago in 2018, which was quite a long time ago now. It's quite weird to think back to 2018. It was definitely before this, which itself was definitely before that. But I was working part of a team that was building bespoke broking and underwriting software for one of these specialty insurance firms, and it was very strange project. It was very business analyst heavy. We often joked that there was lots of more project managers and business analysts than there were developers working on this. And we were actually working offsite with another consultancy at the point, and there's all these project managers and business shuttling backwards and forwards between buildings, trying to give us little snippets of the business domain that we were trying to understand. And yeah, we were kind of always found ourselves desperate to learn a little bit more about the business. We was really struggling to understand how the domain worked. We always felt like no one was really explaining it to us. But one day we got to the story, so you could call it, for dealing with these underwriting lines. They described how the policy, the risk of the policy be split up between different underwriters in the market. And so we went away as developers thinking, well, these are, the market splitting the risk between themselves. We'll call these things market splits. And we went away, coded that up, and we shipped it to production. And it wasn't until later that the domain experts started coming back and talking about underwriting lines. And we said, what's an underwriting line? And they said, oh, it's like a share that an underwriter has on a risk. And we're like, oh, it's cool, we've got that. That's market splits. And they said, what's market splits? And it's like, they're underwriting, they're the same thing, don't worry. And this kind of just went on almost for months as a joke. And every time a new developer joined the project, we'll explain to them what a market split was. And every time a domain expert came in and said underwriting line, we had to go to the new developer and be like, that's a market split. And we just really wasn't speaking the same language. Especially in high pressure environments, you might think of it as a joke. It might be a small thing that you do keep in your head, but often with the pressure of always delivering new features, you don't necessarily always get the time to go back and prioritize this. And this, I discovered, kind of happens more and more in the world of programming. And sometimes you say you have a concept as simple as an account. Like, what is an account? Is it a bank account? Is it a user account? Like in the banking domain, you could definitely imagine these both being entities that exist within the world in which you work. But in this case, it's the same word, but it has an entirely different meaning. And that's quite common, especially with a word like account, where your physical savings account is very different to your online account for accessing your online banking. But sometimes it's more subtle. So if we take a dive into the world of book publishing, you can kind of think about it in different areas of the business. Perhaps when you're drafting a book, you certainly wouldn't have the ISBN number for a book at this stage. You might not even know the title of it. It might just be a suggested title. When you'll probably know who the author is, because normally it's that kind of stays constant throughout. But you might have to identify it by something else, perhaps a draft ID or a book ID, or a book might have multiple drafts. But then perhaps when you're finished drafting your book, you hand it over to the editor, and context slightly changes a bit. While you might now know what the title is, and the author's still the author, you've now got an editor in the mix here. But the editor didn't make sense back when you were drafting it. You hadn't even submitted it for editing yet. and this goes through, you publish it, and perhaps at this stage you get your ISBN. I should caveat with all of this with the fact that I don't know anything about publishing, and I'm just kind of pretending, or at least guessing what this domain might look like. But I hope you can bear with me and that it works. But yeah, I suppose by the time you've published a book, it has an edition, and the title and author will definitely be fixed at that stage. But in perhaps another part of the business, say the warehouse, the title and the author is completely redundant and you don't care about it. Maybe it's not something you would ever need to consider, but you would have to consider where it is in the warehouse, its location, and how many of that book you have. And maybe you need to know whether it's publicly released or not. Because of course, if someone's just shipped you loads of books fresh off the press, but it's the new Harry Potter and it hasn't come out yet, you'd certainly want a safeguard in place to make sure you don't accidentally ship it out anywhere. But in the shipping domain, perhaps someone's bought this book and you're shipping it out to them. Again, it changes altogether. I now know a load about this domain, and you even know the dimensions on things to know what type of vehicles they can go in and their weight, so that you can make sure that those vehicles don't become overloaded and above their legal weight. There might be restrictions as well, maybe not so much in a free economy like the UK, but I'm sure there's areas around the world that you're not allowed to ship certain types of books to, and perhaps they're seen as politically sensitive. And in purchasing as well, you probably don't care about the weights, the dimensions, or restrictions, but you do care about the reviews, so you can present those to your user. There's something really crucial here that I've forgotten, which would be the price as well. Of course, you'll need to know what the price of that book is. And this is a lot more common. You see these scenarios where you have like some concept in your domain, but it actually has a slightly different meaning depending on who you talk to. But before we dive kind of further into DDD, I just want to cover some basics. And obviously DDD meaning domain-driven design, it begs the question, well, what's actually a domain? And here's how the Oxford English Dictionary puts it: an area of knowledge or activity, especially one that somebody is responsible for. And you might be sitting there thinking, well, yeah, that's great, but how does that help me? What does that mean? Like, is banking a domain, or is that part of financial services? And does banking have domains within it? And so, well, yes, it does. And in domain-driven design, we'll also talk about subdomains, which, if you ask me, it's also just the domain. Domains are like very relative to each other. Within banking, for example, you'll have other domains like personal banking and business banking, but it's murkier than that. It's a bit fuzzy. And if you take a look at another dimension, you might have loans or investments. And I'm sure in banking you can go even further and dive into that. And under investments themselves, there will be a whole different load of categories of subdomains, of areas of interest or knowledge or responsibility within those. But this is hard. We want to start thinking about our systems. We want to say, well, how do we start making sense of these big complex domains and start building software that's useful within them? And in the world of domain-driven design, we also talk about these concepts of core, supporting, and generic domains. So suppose you were, I don't know, Stripe early on in their lives. Payments were probably your core domain. They were central to your business. They were what you was known for. You were probably the first to market. I don't know if Stripe were. There were probably other areas, but Stripe back in the day, they got there quickly and they did it well. But core domains, they come in different types. Sometimes, they're quite decisive, and they have like a high level of business differentiation to them. And in those scenarios, you're good. You're in a stronghold, right? You want to spend lots of your time, lots of your organization's energy on that part of your business, and then make sure that you're doing it really well. But sometimes these core domains can be a little bit different. Sometimes it's like a first to market core. And perhaps that's what's happened here with Stripe, because as we know, like later on, loads of other people started flooding this market. And I don't know too much about Stripe's business model, but over time, that payments domain or subdomain isn't so much of a strong point anymore. That doesn't differentiate you enough. You're going to start losing market share if you focus too much on there. So you might have to differentiate. And over time, you might start creating really intelligent and clever fraud detection algorithms, at which point they become your core domain. That's how you're differentiating yourself from the rest of the market. And the payments domain that was formerly your strong point becomes more of a supporting affair. But there's other types as well, you know. I don't know if you know the story of Slack, but Slack was just like an internal tool on the side at well, I believe it was a games company. I can't remember. Maybe someone can clarify. But they started, they built Slack on the side. They thought, this is really good, and perhaps we should, sell this. And they did. And of course, now that's a multi-billion-pound business, which I believe has since been sold to Salesforce. Arguably AWS as well. They were in the business of book selling and online product selling, and I'm sure very early on the domain of hosting was very much a generic thing on the side that they thought perhaps they could even buy off the shelf or get elsewhere. But over time, that has arguably become their core business asset. It's definitely where Amazon see a lot of their growth. And I suppose what's good to kind of acknowledge here is that someone else's generic domain is someone's generic domain is someone else's core domain. Like I don't think of payments in the business I work in, groceries, a core thing at all. But I wouldn't say that to a payment provider. But yeah, as software developers, we're trying to create kind of useful models or representations of the domain in which we're working and code them up, right? That's, we want to make a useful representation of the world that does something, provides value to our business. But, it begs the question, with all this complexity, with all these domains and subdomains, and they overlap and they're fussy, what models do we make? Where do we draw the lines between one model and another? And this is where, in the vernacular of domain-driven design, we start talking about bounded contexts. And I kind of hate the word bounded context because the word bounded is a bit confusing. I don't think anything's like purely bounded or completely bounded. Think of the boundaries as a little bit fuzzy, but we want to start thinking about a part of our domain where we can usefully work on it and provide value to the business, and where everybody working on that project has a clear, unambiguous kind of definition for every term that you're using. And that's not just the developers, that's the domain experts, your analysis, and even the code itself. We want to use that language in every way that we work. But it's hard, and there's a load of different strategies to trying to understand what these bounded contexts are. Traditionally, you might think of them aligning with subdomains. In some of the seminal books that came out about domain-driven design, there was clearly this encouragement to align your bounded context up with subdomains in your business. But as we saw a few slides back, domains are overlapping, and you can look at your business in multiple different ways and remodel those subdomains and those bounded contexts to align in different ways and to collaborate in different ways. And while I'm not going to go into it too much today, there's lots of tool sets out to do this. There's an activity in particular called event storming, which is a collaborative domain modeling exercise where you get all your domain experts, your developers, analysts in a room, and you start mapping out events that happen within the business. Now, these aren't technical. You won't be talking about submitting forms or particular systems or microservices or modules in your code at all. You'll be trying to think in terms of the underlying business. You're trying to think as if the technology wasn't there at all. And when you map these things out in terms of events, those discrete things that have happened in the past, perhaps order shipped or order placed, you start seeing kind of a timeline appearing, and you'll see like multiple swim lanes where sometimes things are going on in parallel, but you also see pivotal events as well, which kind of mark clean boundaries between one part of your business and another. So if we take another look at the book publishing domain that we looked at a little while ago, you could kind of imagine drawing these up as your bounded context. Now, again, I don't know much about the domain, so you'd have to go and do all those domain modeling exercises with your colleagues and with your domain experts and play around with where you might want to draw these boundaries. But let's, for argument's sake, should say that we pick these boundaries. You could kind of imagine that drafting having a lot of activity in it, but you might at the end of that process, finalize your draft, and a draft finalize event might be the entry point into the editing process, and the same between editing and publishing, or when the final edit is approved or whatever. It's in these ways that we can start now forming our models and using different models for each part of our business in this way, such that we can start having a code base which isn't cluttered with the responsibilities and capabilities of other parts of our business, and the people working in that area can start having a much clearer, more concise and less ambiguous definition for everything that they're working on. Now, I know what you might be thinking. Aren't these just microservices? And this is where things have got kind of blurry over the years. I think because of the rise in microservices and the popularization of them, and perhaps even the cargo culting of them, people very quickly learn that building microservices out, just because, or just thinking that you've got a new entity and shoving it in a new microservice, is a really painful experience to go through. If you can't encapsulate your microservices around your business capabilities, you're going to find it really hard to draw those boundaries. You're going to end up in situations where everything's talking to everything, and you'll end up with systems with really high latency. And I think over the last few years, we've seen kind of people kind of claw their microservices back in to realize that they were kind of doing it wrong, and it was becoming a bit of a mess, and they needed to start thinking more in depth about how they were drawing those boundaries. But they don't need to be microservices. You could also draw your boundaries as just modules within a monolith. There's nothing wrong with a monolith. It's often, they're kind of seen as analogous sometimes, I think, with big balls of mud, and if you want to solve it, you need to build microservices so you can cleanly separate all your code. It's like, well, no, that doesn't really work. The clean separation comes through this clean encapsulation where you hide away as much information as you can about each business capability and limit the extent to which communication is happening between your systems or between the components or modules of your system. Because effective communication is key, but you want to make sure that your communication counts. If everybody in a business was talking to everybody every day, it would be chaotic. No one would ever get anything done. You want to start forming departments and specialisms where they can do work by themselves without needing lots of dependencies on other teams. But they still work and collaborate with other teams. They just over time form really stable, well-defined contracts for how that happens. Now, I've spoken about domain-driven design for over 20 minutes now, and quite often, I think a lot of people's first introduction to DDD, or when they first hear about DDD, and this is definitely my experience back when I used to work a lot in PHP, is they think, oh, isn't that what the repository pattern's all about? And this is where domain-driven design is actually split into two large areas. The strategic stuff is what we've been talking about so far. Strategic DDD looks at the conceptual whole. It looks at the capabilities of our organization and starts to think about how we can break that up into a set of subdomains or capabilities that we can model effectively that mean something to our business. Whereas if we go further back in my talk where I was talking about that market splits example, that was a case where we had a misalignment between the code itself and the language of the business. And that's the part where tactical domain-driven design comes in. Is everybody still here? I realize I can't see the talk at all, so we're all good.
Still here, we can see it.
Fantastic. It just occurred to me that if my Chrome had crashed, I wouldn't have known. That's good. So one of the first tactical kind of patterns in domain-driven design is that of a value object. And a value object is, well, it's defined by its value. And here I've got the example of a color in RGB kind of format. And two colors with the same amount of red, green, and blue, well, they're the same color. You can kind of just look at the two colors, and if they've got the same red, the same green, and the same blue, well, they're the same thing. You shouldn't really be modeling them as separate things or thinking about them any other way. If they've got the same components, they're the same color. But value objects do a lot more for us. They help get these domain language into our code. They can encapsulate this, like the parts of a particular entity. In this case, red, the red, green, and blue that makes up a color. But they can also hide business logic as well. I haven't done it in this example. It wouldn't have fitted on the slide very well for one, but there should at least be some validation of the red, green, and blue. Are they within the right parameters? Are they of the right types? But they can also hold other business logic as well. And here I've got the example of mix with, to mix a color with another color. But crucially, notice how I return a new color when I do that, because it doesn't really make sense to change a value object or mutate a value object, because if you do mutate it, if you mutate a color, well, it's just a different color now. So here we return a new color. But because of this immutability, we get thread safetiness as well. You can safely operate on these things in different threads and know that you're not causing any problems. But there's lots of other kind of classic examples, money being one, or if you're dealing with the relationship between two different types of money, say a currency, you might have a currency which itself is forms of money objects. And sometimes for just other things as well, perhaps the identifier of an object or a national insurance number. There's lots of cases that pop up in our domains where a value object can be a really good way of encapsulating some information. But this isn't the case, where they're identified by their value. This isn't always the case. Sometimes you have entities in your system, such as an employee. Like two employees can have the same name, but it doesn't mean they're the same employee. We need a way of telling them apart. So we have entities as well. And unlike value objects, which are compared or identified by their values, entities are identified by their ID, and they are now mutable. And while in the case of an employee, you probably wouldn't want to change their name, but they might have reasons for doing so. Perhaps they've got married, or perhaps they have changed their name by default. And entities themselves, they will consist of other value objects. So most entities, well, all entities have an identifier. Sometimes that can be a unique ID, like a UID, but sometimes it makes sense to use a more domain-centric identifier. So in the case of an employee, you might identify them by their national insurance number. But the national insurance number itself is a value object. If you've got two national insurance numbers that have the same underlying number, well, they're the same national insurance number. I don't know if you've seen this. This is all Java. For those not unfamiliar with Java, Java has a concept or construct of records. I think you've got a similar thing in PHP now to simplify the construction of like DDOs. Is it like property constructor promotion or constructor property promotion or something? This is just like a shorthand way of saying you've got a DTO here, effectively a name which has a string of first name and a string of last name, and here with a national insurance number. But we also kind of want to, our entities are encapsulating kind of hidden data or data that belongs within them, but we shouldn't really be operating on the data directly. So I don't expect to see a bunch of setters for all the different properties of an entity. Really, entities are operated on by domain operations. So you don't create an employee. An employee isn't something you create. Otherwise, recruiters wouldn't exist. Well, maybe that'd be a good thing. Who knows? But really, perhaps depending on your domain, you enroll an employee. That's how you create them. So you notice here that I've actually made the employee constructor private, and I've used this static method instead that is public, called enroll. And this is the entry point. This is how you create. This is the factory method for how you make an employee within this system. And where you might have getters for them so that you can, from outside of the employee, find out information about it. You'll normally operate on the data through various methods that represent your domain operations. There's probably room improvement here as well. You might notice I've got just using a plain old integer for age. At first I thought, it's just an age, it's just a number, an int will do. But actually, the more I think about it, perhaps a value object would make sense here. Some ages perhaps aren't valid, especially negative ones. And perhaps you might have a limit on age. I don't know. It depends on your organization and how it works and your domain. But now we have a question. If entities can be made up of value objects, and while this example doesn't, other entities, things that are identifier, why, perhaps, an employee might have a locker. How far do you go? Where do you go with this nesting? So, in principle, you might think that a customer has many invoices. So that kind of makes sense. There's many invoices raised against this customer. That's language you might use in the real world. But also in some systems, we think of it more like this, where a customer would have an ID, and instead of nesting invoices associated to that customer within the customer entity, we might just have completely separate invoice entities where each invoice references a customer ID. So the question is how do you choose? And this is like another key kind of construct and concept within domain-driven design. So let's talk about the trade-offs. If you're dealing with larger objects with a greater level of nesting within them, where you're loading more and more entities underneath them, you're involving, you're reading and writing more data every time you persist or retrieve those from the database. You're loading more data into memory. But I suppose more cynically or more seriously, you're going to experience more contention. When you have very large entities, you're increasing the likelihood that two different users within your system are going to want that entity at the same time. And what do you have then? You have concurrency problems. If two users read the same version 1 of an entity simultaneously, and user number 1 goes and operates on that entity, and then shortly after user 2 goes and operates on that same version 1 of the entity, user 2 is going to have a problem persisting that version, because when it gets to the database, it's going to realize that the version it's updating has since been overridden. And that's the chances of that happening increase as we increase the size of our objects. We're increasing the chances that more than 2 people are going to want it to use it at once. But also sometimes in our systems, we need to use a level of nesting. We need to have entities that relate to each other, because sometimes there's invariants or business rules within our domain that mean 2 pieces of data always need to remain in sync. There's lots of different examples of this, but perhaps you want on an order, if a customer has a per order credit limit, you might want it to be the case that the line items on that order can't exceed the credit limit. And you can't do that if they're completely separate, completely entities. And this is what aggregates give us in domain-driven design. An aggregate is just a kind of a tree, if you like, of entities and their value objects, but where they form a conceptual consistency boundary. So you want these to be as small as possible, because the smaller they are, the less likely it is that two different users or use cases are going to want to access them at the same time. But they need to be big enough to enforce their own business invariants or their own domain rules. So yeah, an aggregate's always consistent within itself. It's always owned by an entity, which we call the aggregate root, but it is just an entity. And you always access and store an aggregate by its aggregate root. So you would never, from another aggregate, reference an entity that isn't an aggregate root. You always reference an aggregate by its root. And because of this, because they form this conceptual consistency boundary, we're able to limit our system so that there's only ever one transaction per aggregate. If you've designed these boundaries well, if you've formed your aggregates in such a way that they do protect their business invariance, there's no reason why you should need to update more than one aggregate within the same database transaction. But sometimes there are scenarios where other aggregates do need to find out about something that's changed in another aggregate, but as a business you accept that can happen later. That's what eventual consistency relates to. But how we deal with this we'll come back to in a minute. But before I can finally talk about repositories, and in domain-driven design, or in software, shall we just say, because domain-driven design has really nothing to do with it. A repository just represents a collection of aggregates, of aggregates of a particular type. So if you've got orders in your system and you've got an order aggregate, you'll have an order repository. And your use cases, so you've got a use case or an application service that you expose that allows a user to cancel an order. It will start off by starting a transaction, getting that order by its ID out of the database, cancelling it, and then persisting that order back. That will be the transaction. But of course, you're going to want scenarios where things are going to want to respond to the fact that that's happened. Perhaps an email needs to be sent. Perhaps some other system, part of aggregate, or even a whole other component within your system. Perhaps in a microservices landscape, a whole other actual deployable unit, a whole other microservice might need to know about this. Perhaps it needs to send a notification. Perhaps it needs to update some sort of reporting metric. And this is where domain events come in. So generally for domain events, they kind of take this sort of very basic structure, and we have commands coming into our system. So in this case, cancel order. The cancel order use case that we just saw will deal with canceling that order or changing the state of this aggregate. But then that aggregate, that order aggregate, will fire a domain event if it's something that the rest of the somewhere else in the system cares about. It'll fire an event raising it against itself. And then you now need to dispatch that event to that other part of the system. But we have a problem. How do we do this safely? You see, we have a bit of an issue here, right? You've got an order. It's raised an event because you've performed some sort of operation on it, and you want to dispatch it to another part of the system. Now, if you save the order first within the transaction and then send your event off to the message bus, you have a problem. If the message fails to send on the message bus for whatever reason, you've saved an order, you've updated the state of an order, but that message is, that news hasn't been spreaded. That news is lost forever. But on the flip side, if you send the event first and go, I'll send that first so I know other people have heard of it, and then I'll save my aggregate, my order, you've got another problem. Because if the event sends, but then something goes wrong with the database transaction, you've told other people that something's happened, but it hasn't actually happened because you've had to roll back the transaction. So how do we deal with this within our systems? How do we make this messaging safer? And this is where we might lean on what's called the transactional outbox pattern. And the idea here is kind of twofold. First of all, you have this order service. In this case, it's cancelled an order. So it's retrieved an order from the database. It's performed the cancel operation on it. That order, as a result, has raised this order cancelled event on itself. And now we want to persist both those facts. But crucially, we need to make sure that they're both stored at the same time within the same transaction. But we don't bother about sending it yet. So what we do is in the same transaction, we will persist the order to its table, but we'll also store the event on it in an outbox. And this is, think of it as like a postbox in a way. These are messages that I mean to send, but they haven't been collected yet. But at the end of that transaction, that both those facts are clearly stored, that the order state has been updated and that this event on that order is ready or pending to be dispatched. And then in the background, you'll have either like some sort of polling mechanism or watch mechanism on that outbox. And in a separate transaction, it will take each message on the outbox, push it off to the message broker, and then mark the message as dispatched. Can anyone see what the problem might be here with this second transaction?
If it fails later, then you have to roll back the state.
So you've already saved your state clearly in here. So you've already know that you've got your orders state updated and the corresponding domain event safely stored, and that succeeded in transaction 1.
No, but if it's stored and you send the event and the event doesn't succeed, then you've got something that's in an inconsistent state because your event says that something's happened. You've stored that it's happened. But when it goes across the wire, this is what state machines are good for.
So one scenario is that you go and send this message, but before you get a chance to go and mark it as dispatched, this fails, right? But that case isn't so serious because in that case you can just try again. You can go and wait for this message broker to fix or whatever went wrong. Maybe it was just a network glitch, and you can just keep retrying to send that message. We're adopting eventual consistency here, so we're not expecting it to be delivered immediately because we're distributing between aggregates, but we know it needs to be sent eventually. But if something goes wrong sending it, we can we can just keep trying again until it works. Or go and fix whatever broken and send it later. That might be a few minutes later, a few seconds later, it might be 2 days later, but it will eventually have that state propagated to other parts of your system. The slight issue that we have is what happens if you send that message to the broker, but something goes wrong before you're able to go and mark it as dispatched in the outbox. In this scenario, you've sent a message, but you don't know you sent it. So you end up sending it again. And this is something you kind of have to accept within systems, or there's ways around it. But generally speaking, you want to adopt the idea of idempotency. And that's the idea that the same message might be sent more than once. And that your downstream consumers, or sometimes your message broker can deduplicate events for you, but you'll normally give your event some sort of unique ID. And if your message broker isn't deduplicating events for you, your consuming systems need to keep track of what events they've seen. Sometimes it doesn't matter, if the event is that you're starring a repository, it doesn't matter if GitHub receives the event twice that you've starred a repository. The end result is that the repository is starred. But if it's something different, like depositing £10 into an account, it certainly can't happen twice. So a downstream system would need to know that it's already consumed that event and try again. So yeah, these are some of the kind of the concepts we talk about in domain-driven design and how we work with them. But I also wanted to talk a bit about CQRS. And we haven't spoken much about queries in our system. We've spoken a lot about the command, the right side of the model, where all the business logic happens, right? Where we're issuing commands and updating state. That's the interesting part of our systems. But really, every user interaction normally starts with a query, right? Where we go and get a list of information or information about a particular entity in our system, and we look at that information, we use it to make a decision. So we first go and get some state, and then we use that state to make a decision before issuing a command into our system to update it. And we normally see that application as kind of one big box. But what that can mean is that lots of the entities and objects within your system start being modeled with both that right side concerns, like the current state of an entity and all that business logic, but also you'll start seeing query related concerns being mixed in with that, and you'll start seeing methods that are being used purely by the query side of your application. So CQRS at its heart stands for Command Query Responsibility Segregation. It's simply this: we split our write model from our read model. And when we say our model, we mean our code models, how we're thinking about our writes and our reads. And that can just be as simple as keeping all of our queries separate, right? So instead of loading entities or aggregates out of our store, or adding loads of methods onto our repositories for various queries and filterings that we use in our system, we could just have query methods or query models or classes that interact with our database directly, and have a completely separate write model that keeps that clean and separated. But there's other forms of this as well. You could just have a database, which is the one that your write model writes to. So this is where your transactions happen within your write model in your database. But perhaps you have a read replica as well that eventually is updated with any of the state changes that happen in your database. And that's the side that your read model uses. Okay, that might mean that your read model is a little bit stale at times. It might be tens or hundreds of milliseconds behind on an average system. But does that really matter? Most of the information we're querying is out of date by the time we issue our commands anyway, just because it's been sitting on our screen for a few minutes while we read it and digest it and decide what we do. So this information being a few milliseconds behind isn't normally an issue. Sometimes you could take it even further than this. You might find that the database that makes sense for your write model, where you're storing your aggregates, doesn't really make sense for your read models. So some systems might use these domain events to update completely different representations of the state of our system. I think we've all worked on systems before with really complex dashboards that are showing lots of information about various different entities or aggregates within our system that our users want to see in our combined form. And normally generating that dashboard involved a very set of nasty join operations in our SQL database to get it into that format, and that obviously hammers our database, and we try all sorts of fancy query caches and things to make that easier. But perhaps we could just keep an up-to-date copy of the state of our system in real time. Every time an order is cancelled, every time an order is placed, we can look at the query views that care about those events, update them in real time, and save that perhaps as a big JSON blob or something in S3 if we like. And then when that query comes in to list the stale orders, perhaps it's as simple as go and get that blob out of S3 and return it to the user. So I know that's a little bit of a detour, but often when domain-driven design, we often build up feeling these kind of rich and meaningful write models and on the command side. And when we do that, it always sometimes feels like a shame to then pollute that with all these kind of query and read concerns. And one way of kind of clearly separating that in our code base and making our code easier to comprehend is just to separate out those read models. And that's what CQRS really gives us. Yeah, and with that, I suppose, thank you, and any questions?
Woo! Woo! I did have one question.
Go for it.
So when we were talking about like, the payment model and the order, one of the things you said is you could replay the event until it succeeds. But so I work on a system where if we issue a payment, we actually do use idempotency and atomicity to prevent something sending more than once. But we actually just stop it because it could be that you have a third thing in the chain. So you go from microservice A or bounded context A, your system that knows about people who have a plan, let's say it's a mobile phone plan. System B knows how to charge the users for that and is in charge of interacting with payment processors. And then the payment processor side could fail and you wouldn't actually want to resend to the payment processor if, for example, it comes back user doesn't have enough funds in their account. But sometimes the middle service can go out while the other two services are still working. So, for example, you might get like a read timeout. Spoke to someone who works for Fiserv, and they're like a huge global payment processing company. They said someone phoned them up and asked why they didn't have a copy of their data. It's because Fiserv took 12 minutes to respond to them, and most people with a security expert, their web request terminates in 30 seconds. But most web frameworks also don't abort that HTTP operation. So what happens is Fiserv process it. It takes 12 minutes, but the middle party never gets told. And if you were to continue to send it back there without some form of locking mechanism that you were talking about, what you would actually happen is that you'd get a loop where you would continually send it and it would just go round in the loop between your first two systems.
Yeah. Often when I see that on systems, it's normally a clue, I guess, that you're perhaps missing a domain concept. Because especially if you're waiting for like synchronous HTTP responses over like these long-running business processes, like the real world doesn't work like that, right? When you walk into Argos and order something at the till, and they say they've got that, they don't freeze the whole shop and be like, nobody move. I hear there's one of these things for Tim. I need to go and get this thing and give it to him before anyone else picks it up.
No, what I'm saying is it doesn't matter if it's asynchronous or synchronous. So the operation goes from system A to system B, right? Whether you freeze time or not, whether it's synchronous or asynchronous, between B and C it can fail, and you're not worried about whether A gets updated. You're worried that system C can update its state while system B becomes unavailable because it's asynchronous. So synchronous or asynchronous doesn't matter. In both situations, it can occur. So in synchronous, HTTP request times out. That was the example I gave because it was easy to think about. But it could be that they send back to you on like a queue, and it's via SQS. And we know that Google went down yesterday, or some of us using Google Cloud know that Google went down yesterday, and that whole provider they're sending to is not there. Like their DNS records aren't even there, so you can't get the message back. So even if it is asynchronous.
Yeah. And then so have you got like a process manager, like an aggregate that's storing the state of this process?
Yeah, we use state machines to overcome it. That was why I was saying when you hop across things. So we actually wouldn't say that we've charged the user this amount. What we've said is we intend to charge them this amount. So we've got that blue tack point so that we can know that that record has had this action. But until it comes back from the other side, we want that user to be able to access their funds. If they've got credits in their account, we only deduct them once, like once we've got the response. So we cue the intention to do something, and we might make certain decisions based upon that. Like you wouldn't want to just surprise someone with, surprise, you've got negative funds. But in most cases, you'll want someone to continue to be able to use their service until they've actually spent their money.
Yeah, and that's a really good example actually of like a payment intent. It's like a concept that that exists within the domain now to represent the fact that that thing's been requested but hasn't actually yet happened. A lot of the problems I see in these systems are when like those domain concepts are missing, and you just ask just have to ask the business, like, well, what would you do in the real world? Like, what would you do if someone had walked into your bank or your branch and asked for this thing, and then something failed to you wouldn't wait for the whole process to go through. They'll store your application or your request or what did banks call them? Not mandates. These are all concepts that are used to represent like a state in a larger process, and the fact that you've requested to do something. Now, sometimes it's really hard to like automate and deal with every possible failure state within your system. And often when you talk to your domain experts and talk about these things, there'll be just some things that happen so infrequently, it doesn't actually, like, you can't actually justify the time to code up all the possible failure scenarios. Sometimes you can just store the state of these processes in some sort of process manager or state machine class, like you say. And when certain states get entered into, it can just alert someone in the business to go and deal with it manually, because it can sometimes be hard to do them all. But yeah, that's a really good example.
Cheers, Tim.